What are the HSC Advanced Mathematics students reviewing before their final exam? Topic 2. Motion. Presenter, Jojo. Motion of a particle in a straight line. Displacement. Displacement measures the distance x of a particle from a fixed point, which is called origin. Displacement could be positive or negative, and it depends on which side of the origin it is on. When the particle is at the origin, the displacement is 0. That is, x equals 0. When the particle is at the right-hand side of the origin, the displacement is positive. That is, x is greater than 0. When the particle is at the left-hand side of the origin, the displacement is negative. That is, x is less than 0. Motion of a particle in a straight line. Velocity. Velocity v is the measure of the rate of change of displacement with respect to time. So, v equals dx over dt. Velocity could be positive or negative, and it depends on which direction the object is going to. If the particle is moving to the right, velocity is positive. That is, v is greater than 0. If the particle is moving to the left, velocity is negative. That is, v is less than 0. If the particle is stationary, it is at rest. That is, v equals 0. For example, v equals positive 3 meters per second means the object is moving to the right at the speed of 3 meters per second. And v equals negative 3 meters per second means the object is moving to the left at the speed of 3 meters per second. Motion of a particle in a straight line. Acceleration. Acceleration A equals dv over dt equals d on dt bracket dx over dt bracket equals d squared x over dt squared. Acceleration is a measure of the rate of change of velocity with respect to time. So acceleration A can be positive or negative, and it depends on which direction the object is in. If the acceleration is to the right, it is positive. It means the acceleration is in the same direction as the velocity. The particle is speeding up, since it is accelerated. That is, A is greater than 0. If the acceleration is to the left, it is negative. It means the acceleration is in the opposite direction from the velocity. The particle is slowing down since it is decelerated. That is, A is less than 0. If the object is going at a constant velocity, there is no acceleration. That is, A equals 0. Motion graphs. There are usually 2 types of motion graphs, including displacement time graph, dt graph, and velocity time graph, VT graph. Summary. 2.1. You can describe the velocity of a particle by looking at the gradient function of a displacement time graph. The slope equals rise over run equals changing in displacement over changing in time equals velocity. 2.2. You can describe the acceleration of a particle by looking at the gradient function of a velocity time graph. Slope equals rise over run equals changing in velocity over changing in time equals acceleration. For example, the graph on the top left is a displacement time graph, dt graph. Starting, the slope is negative, displacement is decreasing until the particle reaches the origin. Then, the slope becomes positive. Displacement is increasing. With velocity time graph, VT graph on the left, starting, the velocity is negative until the particle reaches the origin, where velocity is 0. Then velocity is positive. With the acceleration time graph, AT graph on the left, as velocity time graph, VT graph is a straight line, the acceleration equals changing in velocity over changing in time equals a constant. Motion graphs. 2.3. In the above velocity time graph, the area enclosed by the velocity line and the time axis is the displacement of the particle. So displacement value is the sum of the area of two red-sided triangles. Attention here, the top right triangle area taking away the lower left triangle area, as velocity value is negative during the first period of time. Look at the right graph. In this acceleration time graph, AT graph, the acceleration is a constant. The area enclosed by the acceleration line with time axis is the velocity of the particle. The velocity value equals the value of acceleration multiplying time. That's the end of the summary of motion. Good luck with your exam.